All right, number one says solve triangle ABC. We're given angle A, angle C, and side C. So if we start off drawing triangle ABC, just use some straight lines here. So angle A is 60 degrees, about like that. Angle C is going to 44 degrees. We'll make C over there. Not drawn to scale, but kind of close. So angle A is right here at 60 degrees. We're going to call this angle C at 44 degrees. Side C is 20 degrees. So I've got an angle side setup. So if we're trying to find the missing sides, A and B and angle B, missing angle, I can begin by finding angle B. It's easy enough. So we know that angle B is going to be 180 minus the other two angles. So 180 minus 60 is 120, minus 44 is 76 degrees. And once we know how big angle B is, then it's just a law of sine situation. I know that A over the sine of 60 is equal to B over the sine of 76, which is equal to C over the sine of 44. At this point, I get my calculator out, make sure I'm set to degrees, not radians. And I want to know what the sine of 60, sine of 76, and sine of 44 are, so type those in. Go 4 decimal places in my work, so I'm going to get sine of 60 is 0.8660, sine of 76 is 0.9703, and sine of 44 is 0.6947. Oh, and I just realized C over sine of C, but C is 20. So let me erase that C and put a 20 right there. So just like that, I've got two proportions, this one here and this one here. I can find A and I can find B with those proportions. So if I start out with A over 0.8660 is equal to 20 over 0.6947, taking these two fractions set equal to each other. And all I got to do is cross multiply. I'm going to multiply these and divide by that. So I'm going to get 0.8660 times 20 divided by 0.6947. I like to round I find my two decimal places, so A is going to equal about 24.93. And if I look at the other proportion, which would be made by these two here, that's B over 0.9703 is going to equal 20 over 0.6947. Once again, this product divided by that is going to be B. So 0.9703 times 20 divided by 0.6947. That comes out to B equals 27.93. So as far as solving this is concerned, we know B is 76 degrees. Side A is 24.93, side B 27.93. And that's what solving a triangle is, find the missing parts. Law of sines for the first one. Number two, in triangle ABC, angle C is 75, A is 14, B is 18, find side C. So looking at this triangle, if I can do it justice, about like that. This could be angle C, it's a 75-degree angle. We'll call this side A down here, that's angle A up there, that's 14. Makes this angle B, so side B is over here. Looking at the given information, I want to find side C. I'm looking at a side angle side setup, and that's a law of cosine scenario. Law of cosine says the missing side squared is equal to one side squared plus the other side squared minus 2 times the product of those two sides. Cosine of the angle between. As long as this side is opposite this angle, the law of cosine is set up properly. So C squared on this side, the other two sides 18 and 14 squared and added, subtracted 2 times the two sides 18 and 14 times cosine again of the angle opposite the side we're looking for. All this is a numerical expression. My calculator can evaluate that straight out. So if I type in 18 squared plus 14 squared minus 2 times 18 times 14 times cosine 75 equals, make sure I'm in degrees, and I am, equals. And we then end up with C squared then has to equal 389.5552. which means C is going to be the square root of that. And that comes out to about 19.74. And all they're asking me for is side C, so that's the end of the problem. If I needed to find side A or side B at that point, I'd probably use the law of sines to find A or B, then subtract from 180 to find the other one. But again, all they're asking for is side C, so stop there. Number 3, we have a triangle ABC, 3 sides. A is the longest, B is second longest, and C is the shortest. So let's just say that this is 40 down here, we'll call this 34, and this is 31. Side C is opposite angle C, side A is opposite angle A, and side B is opposite angle B. It says find angle B, which is this angle over in the corner. Side is a law of cosines again. And since I'm trying to find angle B, I want to use 34 on the side by itself, so 34 squared goes over here, and 31 and 40 go on the other side. So equals 31 squared plus 40 squared minus 2 times 31 times 40 cosine of B. Again, as long as this side goes with this angle, we have it set up properly. And the thing to be cautious of with the law of cosines is that all this stuff here grouped together is one object. So all this stuff belongs to each other. These 3 things are all independent. So I'm going to move the 31 squared and the 40 squared over there to deal with the 34 squared. I'm going to evaluate a couple things first though. So if I type in 34 squared, I get 1156. 31 squared is 961. 40 squared is 1600. And then for this extra term, if I do 2 times 31 times 40, that comes out to 2480, and it's minus that. So minus 2480 cosine of B. And again, people are tempted a lot of times to subtract that. All this stuff's connected together. These guys need to move over there. So I'm going to take the 961, so minus 961, and the 1600 minus 1600 over the other side. If I carry it out, the addition and subtraction, 1156 minus 961 minus 1600 comes out to negative 1405 on the left-hand side, equals negative 2480 cosine of B on the right-hand side. At this point, I want to get cosine of B is equal to a number, so I divide both sides by negative 2480. That gets cosine of B all by itself on the right-hand side. If I do negative 1405 divided by negative 2480, it comes out to a decimal 0.5665. So cosine of B is equal to 0.5665, which means B is going to equal the inverse cosine of 0.5665, which my calculator can tell me. Get the inverse cosine, second cosine to get there. And 55.49 degrees is the value of B. Again, that's all they asked me for is B, so that's it. They asked me to find A or C also. I would probably do the law of sines to find C, because C is an acute angle. A might be an obtuse angle. I wouldn't want to use a law of sines to do that. So once I found out what C equaled, then I'd subtract 180 to find A. But again, they're only asking for B, so that's all you have to find. Number 4, we're given 3 sides of a triangle ABC. We're supposed to find the area. In a side situation, we're going to use Hero's formula. Hero's formula requires us first to find half the perimeter. Half of 20 plus 30 plus 40. And perimeters just add up the 3 sides. 20 and 30 is 50 plus 40 is 90. Half of that is 45. And then once we know the value of S, the area of the triangle is going to be the square root of S times S minus each of the 3 sides. So 45 minus 20 is 25. 45 minus 30 is 15. 45 minus 40 is 5. And once you have the structure of the right answer, then you simply have to type that in the calculator. So hit the square root button and then type in all the numbers. So 45 times 25 times 15 times 5. And that comes out to 290.47. And that'd be units, or doesn't give it units, does it? Nope, units squared. For number 5, using the formula cosine of alpha is equal to u dot v over magnitude u magnitude of v, find the smallest positive angle to the nearest degree between these vectors. So if I use that formula, cosine of alpha is equal to u dot v is going to be 2 comma 5 dot product with negative 4 comma 2 over the magnitude of u, which is just the square root of the sum of the squares of the two pieces, so 4 plus 25, and the magnitude of w is the sum of the, or sorry, v, sum of the square of the two pieces is going to be 16 plus 4. So we're going to get cosine of alpha is going to equal 2 times negative 4 is negative 8, plus 5 times 2 is plus 10, all over the square root of 29 times the square root of 20. So that gets me to cosine of alpha is going to equal positive 2 over the square root of 29 times 20, which is 580. So in my calculator, I'm going to type in 2 divided by the square root of 580, and that comes out to 0.0830. Cosine of alpha is equal to 0.0830. So therefore, alpha should be the inverse cosine of 0.0830. And again, my calculator knows the answer for that. So inverse cosine, 0.0830 equals 85.24 degrees. Formula will be written on the test. You just have to know how to use it. And again, it's always an inverse cosine at the end. So everything you do is towards getting this number. Once you get that number to a decimal, inverse cosine of that number gets you the answer you're looking for. Number 6, write that in trigonometric form. So 3 steps in the process. Step 1, the magnitude is going to be the square root of this squared plus this squared. And when we square 2 squared root of 3, it's 4 times 3, which is 12. That gets me the square root of 16, which equals 4. Step 2, alpha is equal to the inverse tangent of the absolute value, so absolute value just makes everything positive, of the vertical over the horizontal, so the imaginary over the real. So 2 square root of 3 over 2. That's just inverse tangent of the square root of 3, which equals 60 degrees. And then finally, step 3, we have to establish a quadrant. A real number positive takes me right, an imaginary number negative takes me down. And if I go in a 4-quadrant system and go right and down, that puts me in the 4th quadrant. In the 4th quadrant, theta is equal to 360 minus alpha. So the magnitudes for the angles 300 degrees, we want R CIS theta form, so R is 4, theta is 300. So 4 CIS 300 degrees. And I do expect it to be written in that manner. So it's going to have the structure right there for you. You simply have to figure out these two numbers. Make sure you write it in the proper form with the CIS. Don't give me the polar form. If you give me that, you're going to lose some points because that's a different meaning than this. So we're not looking for that form. Make sure it's got the CIS written on it. Number 7, find the square root of 3 plus I to the 3rd power. Write the answer in standard A plus BI form. So first thing I would do is convert this into CIS form. So step 1, R is going to be the square root of 3 plus 1. Square root of 4 is 2. Step 2, alpha is going to be the inverse tangent of 1 over the square root of 3. That's the same as square root of 3 over 3, which is 30 degrees. And then step 3, theta is going to be, if I'm going to the right and up, positive right, positive up, up, right, and up. This is in the first quadrant. In the first quadrant, theta is equal to alpha. So 30 degrees is the theta. So this imaginary number is equivalent to 2 CIS 30 degrees. Raising that to the 3rd power. So if I take 2 to the 3rd power, I'm going to get 8. And 30 times 3 is 90 degrees. So de Moivre's theorem tells us that if we're raising a trigonometric structure to a power, the magnitude gets raised to the power. 2 times 2 times 2 is 8. The angle gets multiplied by the power. So we get 8 CIS 90. Recall that CIS stands for cosine of the angle. Cosine of 90 is 0 plus I sine of 90. Sine of 90 is 1. And then if I multiply that through, 8 times 0 is 0, 8 times 1i is 8i, so the answer is 8i. And it does say to write in standard a plus bi form. Show all your work. If you get the correct trigonometric form and then somehow mess up getting to the standard form, you're going to get most credit for this. Converting to the proper form is probably maybe 2 or 3 points, but the majority of the points will be going towards actually getting the correct result, and then converting back to the standard form is going to be just a couple more points after that. Number 8, divide these two, and according to the division rule, as long as you're in trigonometric form, I simply need to divide the numbers in front to get the number in front. So 30 divided by 5 is 6, and I subtract top angle minus bottom angle. 175 minus 295 is negative 120. That's the correct answer, but it's not good enough because we don't want an angle that's negative. So it does say to write the final answer in RCIS theta form. There's an understanding that theta is supposed to be a positive angle between 0 and 360. So the fact that this is not, what I have to do is I have to add 360 since it's negative. Negative 120 plus 360 is 240, and 6 CIS stays the same. Get me here, you get probably 6 out of the 8 points. You got to get me all the way to the nice, correct trigonometric structure to get full credit. Number 9, use Dumont's theorem to find this. Write the answer standard a plus bi form, round constants to the nearest thousandth. So there's an understanding with the rounding that we're going to not get nice exact answers like we have on some of these other ones. Thousandth is 3 decimal places. If I want my final answers rounded to the nearest thousand, 3 decimal places, I probably want my decimals in my work to go 6 decimal places just to get some accuracy to the 3 decimal place mark. So if I'm going to use Dumont's theorem, I first have to change standard form to trigonometric form. So step 1 is r is going to equal the square root of the square root of 5 squared, which is 5, plus 2 squared, which is 4, square root of 9 is 3. Step 2, alpha is going to be the inverse tangent of the imaginary part 2 over the square root of 5, the real part. This is one that's not on our formula sheet, so I'll probably have to use a calculator. Inverse tan 2 divided by square root of 5. And that gets me 41.810315 if I go 6 decimal places. 41.810315. And finally, positive, positive. Once again, if I'm going to the right and up, that puts me in the first quadrant. So step 3, theta is going to equal alpha. So my RCIS theta form for this specific number is going to be 3 CIS 41.810315 degrees. We're raising that to the 5th power. So what I have underlined here matches this. And it's to the 5th power, so it's still to the 5th power. So now I'm in trigonometric form. I can use Dumont's theorem. Again, I take the magnitude to the power. 3 to the 5th power is 243. Then I got to do the angle times the power. So if I take 41.810315 times 5, that comes out to 209.051575. Alright, that's the correct answer in trigonometric form. We want the standard form. So the final thing I got to do is I got to do cosine of this angle, and I have to do I sine of this angle, times 243. So 243, if I type my calculator, cosine of that answer, it's going to be negative 0.874183. If I do sine of that answer, sine of 209.051575, that comes out to negative 0.485597. So the final step then is to multiply both of these numbers times 243 and round those answers to the nearest thousand. So this times this, and this times this. This one has an I on it. So 243 times negative 0.874183 comes out to negative 212.426. And again, I round that to the nearest thousandth, so 6, 4, keep it to 6. And 243 times negative 0.485597 comes out to negative 118.000. And that's good enough. 3 zeros followed by a 0. It's just exactly 118 for rounded to 3 decimal places. If you want to put the dot 000, that's not wrong. So that's it. That's the answer to that one, again in the correct form. Once again, getting me to this answer here, if you want to stop here, make sure you round it 0.052 to 3 decimal places. I'm going to expect that your final answer, whatever you consider to be your final answer, everything's rounded to 3 decimal places. But go 6 in your work until you get to the point where you say, this is my final answer, then make sure you round that one. This gets you full credit, this will get you probably 6 out of 8 points credit. Number 10, find the 3 cube roots of negative 64i. So if we imagine the real axis and the imaginary axis, negative 64i would be this vector right here, straight down. Its length would be 64. Its angle would be 270 degrees. So this right here in trigonometric form is 64 CIS 270. We're supposed to find the 3 cube roots, so I want to cube root it. In order to cube root an imaginary number, we need to be in trigonometric form. Using the Moivre's theorem, it says that we take the cube root of 64, which is 4. We take the angle divided by the root. 270 divided by 3 is 90. So we root the magnitude, we divide the angle, we get an answer. We also get a magic number, which is always 360 degrees divided by the root. The root here is 3. 360 divided by 3 is 120. That's how much I keep adding to the angle to get each next answer. So 4 CIS, so plus 120 is 210. 4 CIS plus 120 is 330. And then finally, those are all trigonometric form answers. So again, out of 8 points, that would be 6. If we want to go to standard form, that means 4 times cosine of 90, which is 0, plus I sine of 90, which is 1i. 0 times 4 is 0. 4 times 1i is 4i. So that's one of the answers. 4 CIS 110, the cosine, or sorry, 210. Cosine of 210 is negative square root of 3 over 2. Sine of 210 is negative 1/2, and that gets multiplied by I. 4 times negative square root of 3 over 2 is negative 2 square root of 3. 4 times negative 1/2 is minus 2i. And then for CIS 330, the cosine of 330 is the positive square root of 3 over 2. The sine of 330 is negative 1/2. Multiply 4 through that, we're going to get positive 2 times the square root of 3 minus 2i. These answers get you full credit. These answers will get you 6 out of 8 points. So at least have this written on your paper, and if you somehow mess up getting to this point, you'll still get your 6 points. You'll just lose your 2 points for not doing this correctly. Don't not try those, so make sure you make the effort. C cosine plus IS I sine. Cosine of 90, I sine of 90. If you don't know what cosine and sine of 90 are, it's on your sheet. You'll be able to use that during the test. 11. One ship leaves the port at 3 p.m. at a heading of 67 degrees. At 4 p.m. another ships leave the port traveling at 21 miles at a heading of 122 degrees. So if I were to draw this, let's say that I put a north and south line right here. And let's put the port along the north and south line somewhere. And ship A is leaving the port at a heading of 67 degrees. So 0 degrees is straight up, 67 degrees is going to be going this direction. The 67 degree angle is measured from the north-south line to the vector clockwise. The other ship is leaving the port, same port. This one's a heading of 122 degrees. So straight up is 0, straight right is 90, and then 32 more. It's 122, so probably around this line here. Going a little bit faster, but not the same amount. We'll worry about the distances in a minute. Okay, so if I were to measure this, again, from the north-south line clockwise to the ship's path, that's 122 degrees there. And the question is, find the distance between the ships at 6 p.m. So before I worry about finishing this picture, I might want to make one of these longer or shorter. The first ship starts at 3 p.m. It's heading at 15 miles an hour and it ends at 6 p.m. That tells me from 3 to 6 is 3 hours. 15 miles an hour for 3 hours is 45 miles. The second ship is going 21 miles per hour starting at 4 p.m. ending at 6 p.m. So 2 hours that it traveled times 21 miles per hour gets it 42 miles as a distance. So the second ship actually has a shorter path than the first ship, so let's just shrink that down a smidge. That's maybe too much, there we go. Doesn't have to be drawn to scale, but it'll have to be kind of close. So what we're looking for is how far apart are the ships here. That's what we're looking for, is the distance between the ships at 6 p.m. Alright, so what I can do is I can obviously see that 45 and 42 are both two sides that I know. I'm looking for the length of this side, x. And in order to find the measure of x by the law of cosines, which I see is going to be useful in this one, I have to figure out how big this angle is. So this angle is 122 and this is 67. So small plus small equals big, so big minus small equals small. So if I do 122 minus 67, that comes out to a 55-degree angle right here inside the triangle. It's very key that we always get an angle inside the triangle. We're trying to work these problems out. And then again, it's a side angle side situation, so it's very much like, I believe it was problem number 2. It's just the law of cosines. We know x squared is going to equal 42 squared plus 45 squared minus 2 times 42 times 45 cosine of the included angle 55 degrees. In law of cosines, as long as this side and this angle are the ones on either side of this structure, you're going to be getting the right answer. Again, that says x squared equals, so if I type in 42 squared plus 45 squared minus 2 times 42 times 45 cosine 55, still in degrees, it equals, I know x squared is equal to 1,620.8811. So x is going to equal the square root of that. Which comes out to 40.26. Please make an effort to prepare well enough to be able to draw this picture properly. It's going to be involving heading only. Heading starts at 0 degrees, measured clockwise around the circle, around the origin. And again, just kind of use your angle addition postulate ideas. Small plus small equals big, big minus small equals small, that kind of thing, to figure out the angles inside the triangle to create the proper structure. So you can go ahead and use the law of sines, law of cosines, whichever is more appropriate to find a missing piece. Number 12, find the 5/5 roots of negative 1/2 minus the square root of 3 over 2i. Write your answers in trigonometric CIS, RCIS form. So, if I want to do 5th roots of a complex number, I want the complex number in CIS form to begin with. So, step 1, r is going to equal the square root of 1/2 squared, which is 1/4, plus the square root of 3/2, which is 3/4. Okay, we got to square both things. 1 over 2 times 2. Square root of 3 over times square root of 3 is 3. 2 times 2 is 4. 1/4 and 3/4 is 1. Square root of 1 is 1. Step 2. Alpha equals inverse tangent of the square root of 3 over 2 over 1/2. That's just the inverse tangent of the square root of 3. And that's going to be 60 degrees. And finally, for step 3, negative real number takes me left, negative imaginary number takes me down. If I'm in the 4-quadrant system, I go left and down. I'm down here in the 3rd quadrant. In the 3rd quadrant, theta is equal to 180 plus alpha, so 240 degrees. So I know that the RCIS theta form of that is going to be 1 CIS 240 degrees, and that's the 5th root. So if I'm doing 5th roots, my first job is to find the first 5th root, which is going to be the 5th root of 1, which is 1, and 240 divided by 5, which is going to be 48 degrees. And then my magic number in this problem is going to be 360 over 5, which is going to be 72 degrees. That's how much you keep adding to 48. So 1 CIS, 1 CIS, 1 CIS, and 1 CIS. Keep adding 72. So 48 plus 72 is 120. plus 72 is 192, plus 72 is 264, plus 72 is 336. They want the answers in that trigonometric form, so we'll circle that and be done with it, and that's the end of the story. So, main idea here is make sure you're comfortable with what form do I need to be in to use whatever theorem I'm going to use. Make sure you're comfortable going from standard form to trig form and back, that kind of stuff. Be able to draw pictures from headings. Any specific formulas, the law of cosines, law of sines, you need to know those going into this test, so be preparing for that too.